Welcome back, everybody. In this video, we're going to talk about standard normal distribution, and we're going to do a couple problems, and we're going to do them a lot like we did the problems with the empirical rule, because we kind of, if you watched my video where we did the calculator trick to use and skip in the empirical rule, then you really kind of already know how to do this. So I'm going to go right to work here, and I'm going to talk about the standard normal curve for just a minute and talk about what's different about it. So here's our notes. Okay, so what we've got going on here says, what's different than a standard normal distribution and a normal distribution might be the question that would pop up. And okay, so a standard normal distribution has a special property that mu is 0 and sigma, the standard deviation, is 1. And then we got a drawing down here of it. Now a z-score that you've been calculating actually converts the distribution is standardized, it says, by the z-score, which it is. So when you do your conversions to get a z-score, you can use it on a standard normal curve or standard normal distribution. But I wanted to show you something too. The calculator, and I've cleared the RAM and reset it, because it comes, if you go to your second distribution and look at your normal CDF, the default setting has a mu of 0 and a sigma of 1. In other words, this normal CDF is built to handle z-scores. Now, you don't need a z-score to use it because you've already seen me go in here and change the mu and the sigma and override it, and you can. But if you get a problem that has nothing but z-scores in it, and you're not given a mean and standard deviation, and it's confusing to you, you're like, well, I'm dealing with z and not an x value. Well, that's the difference. If you're dealing with just z, you can go directly to this. If you're dealing with an x, you need not convert to z-scores to use this tool. So but you got to learn your way around the tool. So, with that being said, let's go to work and do these couple problems. This is my first problem here, and it says the mean song length of Jack's iPad is 3 minutes and 3 seconds, with a standard deviation of 24 seconds. Find the probability that the song to play is no more than 3 minutes and 45 seconds. So when I read this, okay, the one thing that pops out at me right away is that we got minutes and seconds going on here, and these units don't agree. 3 minutes and 3 seconds is some decimal, 3 minutes and 3 over 60 seconds. Okay, we could do it that way. But then this 24 would have to be 24 over 60 minutes, right? So if we can stay in minutes, we got to convert him to minutes. Or we can just go all seconds, which this is 180 seconds. So 183, 24, and down here, this would be 180 plus 45, so this would be 225. Now, the next thing that pops out at me is this right here, no more than. Oh, I didn't do it right. That's something you got to look for. That is showing us that this thing is a left-handed probability that we need to work on, right? If I'm going to go from negative infinity up to 3 minutes and 45 seconds. All right, so there's us thinking our way through it, kind of working out the glitches so we don't get in trouble with this darn thing. So we said the lower bound would have to be, we'll leave that set then. It's already good to go. Upper bound, we want no more than, what we said, it was 225. And I'm staying in seconds here. We had a mean of, what was it, 183? And a standard deviation of 24. And if we calculate that, we get, the probability looks like it's going to be about 0.959 or 0.95, I better use my glasses. 0.959, or I guess 0.960 if we're rounded to the thousandths. So we'd say the probability is, I guess we'll use P as 0.960. Okay. All right. Let me take a look at it one more here. And I actually kind of got this one from Delta Math, so you do have some of these to do. It says, when Skylar goes bowling, her scores are normally distributed with a mean of 185 and a standard deviation of 14. Out of 100 games that she bowled last year, how many of them would she be expected to score between 149 and 166? It says round to the nearest whole number. And that's how you know it came from Delta Math. But okay, so this is looking like we want to find the proportion, and look at this as we know there's 100 games, but we want to know how many games proportionately live between 149 and 166. And if this is normally distributed, which it says that it is. So in the old days, we'd have gone and converted this to got z-scores and used the chart, but there's no need for that anymore. So we'll go directly to work here and see what we come up with. All right, so second, get my CDF function here. Here we go. All right, so my lower bound is, and I can't see the problem now, 149, right? 149. And upper bound is 166, right? Your mean, 185. And standard deviation is 14. I can see that. And we'll find out what percentage lives there. All right, so there's our value. So 0.823 is what we would answer if it was a probability. What's the probability that they score between these? We'd say, well, there's about a 0.8, no, it's an 8.2% probability or 0.082 probability, but we're not being asked that. We're being asked how many. Since now we're going to have to convert this to some piece of that 100 students, because remember, there's 100 students. What are they? People bowling. 100 games. So we got 100 games. So we're going to say times 100. It's already in that nice form for us. So about 8 people would be the answer. It says round to the nearest whole number, so it'd be 8 people. Eight games. I don't know what's wrong with me here. You have to forgive me. And I think that's the last one I've got right here. The problems I've done with you so far in this video and the previous videos in this slideshow should get you through the homework this week. You should not have any tricks, and if you do run into something, give me an email and I'll look at it for you. All right. You guys be safe.